Right, good afternoon, everybody. So today we will continue with a variance analysis, and today we will look specifically at material mix, variance, including material mix and yield, and also the sales mix and quantity variance. So we will look and focus today at material mix and yield. So the best thing to understand material mix and yield, to look at the example. There are some topics, so you need to go and read the definition and read the theory before, actually after you look at the example. And one of them is the material mix and yield. So the first thing you need to understand that if you look at this chart, you can see that material variance is broken down as material price variance and material usage variance, and they should be able to know this. You are familiar with this because we've done it. Yeah. So if you look at the material price variance, you will see this is the difference between the actual price we pay per kilo and the standard price we pay per kilo. And if you look at the usage variance, you look the difference between the actual quantity and the standard quantity. Right. Of course, if we use more quantity of kilogram, this means to produce the same of output, this means it's adverse variance. So this usage variance, we need to break it down more into two elements: material mix variance and material yield variance. Okay? Again, material usage variance, this usage, we need to break it down into the mix and yield. Right. So why do we need to break it down? That's the question, of course, you ask yourself. Why? Okay, I'll tell you why. So now, the only way when we need this, right, when there is a product which consists of more than a type of material, and these materials are interchangeable, right? I'll give you one example. For example, this is a piece of chocolate. Yeah, Ferrero, isn't it? That's my favorite. I love it. Do you like it? Of course, if you look at this, I'm trying to look at the ingredients, but there's no ingredients here. Maybe the ingredients on the package, maybe. Anyway, if you look here, you look at the ingredients, you will not see only one ingredient, material A or material B. You will see maybe more than, I don't know, but you'll see maybe more than 10 materials, including, could be anything, could be chocolate, could be sugar, water, whatever, I don't know, nuts. Yeah. So these are materials, it's one of the material, of course, more than one, as you see, and also these could be interchangeable. Interchangeable mean we put more chocolate than nuts, and we put more nuts than chocolate, etc., etc. So these, we call them a mix, standard mix, right? Standard mix. This is called mix yield, right? Called mix yield, right? When you look at the input, you look at the input, the quantity. We look at the input of materials. The yield, when you look at the output, right? When you look at the output, how many we produced. When we do the standard mix, this standard mix, how many we produce. Are we produce more or less than we expected? Again, guys, when we look at the example, you will really find it much easier. Again, so far, I want you to understand that, of course, as a material mix variance, as you see, larger than expected proportion of more expensive material, of course, that will be adverse variance indeed, but the opposite will be favorable if we if we use a cheap material. For example, if you compare chocolate with nuts, if we put more chocolate than nuts, it might be more favorable because, as you see, nuts is more expensive than chocolate, for instance, or raisin is less cheaper than chocolate, and so on. In terms of the yield, right? Again, the yield talks about what, given all the ingredients you put into the process, did you get out more units of finished product than you expected or not? So we expect, for example, 1,000 units of output. Did we get more or less? That's, you talk about yield. So when you talk about the mix variance, you talk about input, and you talk about the yield, you talk about the output there, right? So for this session, as I mentioned, this is what we need to focus on: material mix and yield. The same idea applies with sales mix and yield, but today I'll focus more on material mix and yield, and we will now look at the example, and after the example, so you should be able to understand it after we look at this example. Okay, so if you look at this example, right, you will see that the standard direct materials to produce 1,000 units of output as follows, right? So the first thing you need to look at is the question here tells you here that where is it? Oh, why not? Oh, no idea. Anyway, so that's 1,000 highlighted, please. Yeah, please highlight this 1,000. Here we go. Wow. Highlight this 1,000 units. Based on 1,000 units, this is our standard, right? This is, guys, what? This is the material, the standard mix. This is what the standard mix. So if you add them all together, right? So this is 1,200 kilogram. Yeah, 1,200 kilogram. Okay. Lovely. 1,200 kilogram. So these kilograms, the 1,200 kilogram, to produce how many units? To produce 1,000 units. So remember, some questions are mainly the question you will look at. It will tell you only one product or 1 unit, sorry, to produce 1 unit. So if produce 1 unit, it will not give you that. It will give you the kilograms only for 1 unit, not the 1,000 units. So to make your life easier, what I'm gonna do right now, I'm going to divide this, right? I'm going to divide this in order to find the input quantity for each unit, only for each unit. Let's do it now. So 600 kilogram, if you divide it by 1,000 units, yeah. So again, 600 divided by 1,000, that will give you 0.60 kilogram. So that's for 1 unit. Okay, that's for 1 unit. So for 240 kilogram, if you divide it by 1,000 units, that will give you 0.24 kilogram, again for each unit. Now if you divide the next one, which is 360, if you divide it by 1, of course, that will give you 0.36. Okay, so if you add them all together, that's 1.2 kilogram. So if you put here line, that's 1.2 kilogram, and that's for what, guys? For 1 unit, for 1 unit. So you need to understand and you need to differentiate between this one and this one. It's really, really important here, right? So again, that's 1,200 kilogram. That's for 1000 units, and that's 1.2 kilogram. That's for 1 unit. Okay, that's fair enough. Okay, so this is the standard mix. So for this unit, right, we expect to use 0.6 of material A. I don't know what's called material A. Let's say chocolate. 0.24 of material B, raisin. 0.36 kilogram of material C, nuts, etc. So these are what, guys? These are the standard mix. This is what they're gonna do, right? They are, as you see, they are, it is more than 1 unit, more than 1 ingredient, and they might be interchangeable. Okay, so this is the standard mix available right now, and for each standard or each material, as you see in the question, it does give you what? It does give you the standard price per kilo. It does give you the standard price per kilo, right? So if you multiply, of course, this by this, of course, that gives you the standard cost, how much would cost for each unit. Okay, okay. So this is the standard cost per kilo for each material, as you see. Okay. Now these are the information, are the standard figures. Now we need to look at the actual figures. When you look at the actual figures, you can see that the actual output 21,000. That's important. Actual output 21,000 units. This is our actual output, and these are the actual materials used, right? So as you see, material A 14,000 kilogram, material B 5,500, C 5,500. So if you add them all together, 25,000 kilogram of 25,000 kilogram, the actual material used. To produce what? To produce 21,000 units, the actual output. So as you see, these information are really important. So you need these information, especially this, and this, and also these. Of course, you need them in order to start and answer the question. So far, guys, what I want you to do so far, before we do the material mix and yield, I want you to do the material mix itself, right? The material usage variance. Okay. So I haven't done it. I think, did I do it? No, I haven't done it. No. Okay. Let's do the material mix. Usage variance. So material usage, okay, variance. If you remember the formula, standard quantity minus actual quantity times standard price. Okay, fair enough. Yeah, as you see, this formula, you need to do it for A, B, and C. So each. So let's start with A. So if we do A, so you can see for A, what is the standard quantity for A? If you remember the way to calculate the standard quantity, so the required kilogram of A for 1 unit, 0.6, you need to multiply it by the actual output. So 0.6 times 21,000 units, okay? 0.6 times 21,000 units equal 12,600. So that's 12,600 minus actual kilogram, 14,000, times standard price, 1.1. That should give you, oh, what is that? Oh my god. Oh, where did I go? Right, let me go back. Yeah, we are here, isn't it? Yeah. Why is it looking like this? Ooh. Okay. Yeah. Okay. So we did say 14,000 times 1.1 equal 1,500 favorable adverse. Okay, here we go. That's 1.1, guys. Yeah, 1.1. 1.1. Okay. So 12,600 for A, 12,600. So 0.6 times 21,000 units equal 12,600 kilogram minus 14,000 kilogram, which is the actual, times the standard price 1.1 equal 1,540 a pound. Adverse. Why it's adverse? Very simple. As you see here, you can see that the actual quantity is more than the standard quantity. So what does that mean? This means we use more kilogram than we expected. For material B, okay, the standard quantity, which is 0.24 times 21,000 units, which is 5,040 minus 5,500 times standard price per kilo 2.4 equal, that gives you 1,104, and this is adverse. Yeah. Okay. So for material B, guys, as you see, that's 5,040 minus 5,500 times 2.4 equal 1,104. Adverse. Again, why it's adverse? As you see, because it's the material used more, the actual material used more than we expected. So the last one we look at is C, material C. Okay. So again, 0.36 times 21,000 units equal 7,560 times actual 5,500 time 1.5 equal 3,090 favorable. Okay. So as you see here, favorable. Why it's favorable, guys? Here it's because the actual kilogram use is less than the standard. That's why it's favorable. Right. So if you add this, right, this is 3,090 favorable. Treat favorable as a positive number and adverse as a negative number. So I would say 390 minus 1,104 minus 1,540. So total usage variance equal 446 favorable. 446 favorable. Yeah. So when you calculate usage variance, you can expect that 446 favorable is the favorable variance across all the ingredients. Now, what we're gonna do right now, this number, the 446 favorable, we are gonna divide it into mix and yield, right? So basically, usage variance equal mix plus yield, isn't it? Yeah. So this usage variance 446 equal mix and yield. So we need to find out how much for mix and how much for the yield. So when I talk about mix variance, talk about the input and the material, and the yield, I'm talking about the quantity, the output. Okay. So let's have a look at and start doing the material mix. Here we go. So when you do the material mix, okay, this is my way, but there are different ways you can do it, of course. So I want you to draw a table 1, 2, 3, 4, 5, 6. As you see, 6 columns. Okay, and for these 6 columns, this one, okay, and this one, you can hide it, and this one. Great. So as you see, from the 6 columns so far, so 50% or 3 columns out of 6, the solution are given. Not given actually, but you can copy paste from the question. So the material, which is material ABC, yeah, that's from the question. If you talk about the actual material usage kilogram, so that's in the question. The material usage, as you see, ABC, and if you look at the standard cost per kilo, you can see the standard cost per kilo. That's in the question, which is 1.1, 2.4, 1.5. Fair enough. So these 3 columns from the question. So fair enough. Now let's start with the second column. We need to do it, right? So the second column we need to do it, which is the actual usage, the total actual usage. What's that? The total actual usage, yeah. The total actual usage was 25,000 kilogram, right? So we need to find at the standard mix, So what do I mean by standard mix? If you remember, I told you what do I mean by standard mix. This is the standard mix, isn't it? Yeah, or this, anyway, the same. Okay, so how to calculate the standard mix? Very simple. If you look what I did, 600, you divide it by 1,200, then you multiply by 25,000 kilogram. So as you see, 600 times what? The total, or 0.6 divided by the total. Yeah, for each one, you divide it by the total, and then you multiply it by what? You multiply it by the 25,000 kilogram, which is the actual kilogram. So if you do each, right, you should be able to find the answer here. That's for A, B, and C. And of course, the total has to equal 25,000 kilogram, because this is the way we need to calculate the standard distributed based on the actual kilogram. Okay, if you've done this column, that's you've done the question, or you've done the material mix, really. That's it. So now you take the difference. So now what you need to do, you need to calculate the variances in kilogram. So you take the difference, that's 1,500 adverse, of course. It's adverse. I put it in a way, if it's negative, it's adverse. But anyway, as you see, because we use more kilogram anyway than this, so this should be adverse. And that's 1,500 adverse kilogram. If you multiply by 1.1, which is the standard cost per kilo, you should be able to find this in pound, 1,650, of course, pound adverse. Yeah. So that's, you do the same for B and C, and in this case, you should be able to calculate the variances, which is 150 pound, 150 pound favorable, 150 pound favorable. So this is the way how you calculate the mix variance, What does that mean really? This means that the favorable mix variance, as you see the mix, we've done it, is, as you see, is favorable. Why is favorable? Because it's due more material C being used, right? So as you see in material C, we have 2,000 kilogram of material C, yeah, 2,000, which is the highest than A and B, and also that's 1.5, which is higher than 1.1, isn't it? Yeah, so that's why it's being, can you see, it's favorable, a little bit favorable, not a lot, but it's the way how it works. Yeah, so this means according to this standard mix, okay, they are doing well in terms of the input and the cost for the material. Now the question the question now, we calculated the material mix. We are happy with this. Fine. Now we need to find out the material yield, right? For this standard mix, are we expected to produce more or less? So that's what we need to do right now when it comes to material yield, right? So now when it comes to material yield in the second column, guys, so there are two methods when you calculate the material yield. I will explain these two methods, but I'm in favor for the table, which is because it just makes much easier than the second method. Okay, let's have a look. If you look at the material yield here, again, what I want to from you guys, I want you to draw 6 columns. Okay, and again, that's column. I'm gonna hide it. Same with this. Oh, it's not hiding. Yeah, same with this. Same with this. Okay, so you can fill these 3 columns easy, as you see, much easier. We see material A, B, and C, and you've got here the actual usage at the standard mix, which is, you can find it from here, isn't it? You just copy paste. And the standard cost per kilo, so it's here, easy. Cool, that's easy, fine. Now what we need to do right now, the second column, which you need to calculate right now, okay, the standard quantity at the standard mix. We're now talking about the standard quantity at the standard mix, right? So, right. So now, okay, there's no total. Right, that's fine. Okay, how we calculate this, right? Same with this, but here, we don't divide by 1,200. We divide by 1,000 units, which is the output in the question. Yeah, because it's the output, the standard output, 1,000. And then you multiply by what? You don't multiply by 25,000 kilogram, which is the actual kilogram. Here you multiply by 21,000 units, which is the actual output. So as you see from the yield perspective, you can see that we are focusing more on the output, the units, and not the kilogram. Great. So if you do each as we did it in material mix, you can see that for standard quantity and standard mix, 12,600, 540, and 7,560. Okay, and again, once you've done this, again, that you almost done all the material yield. What you need to do, you just need to find the difference, which is between this and this. So again, is here the difference is 100, but it's favorable. Indeed, it's favorable, yeah, because as you see here, the actual usage of the standard is less than the standard quantity and standard mix. So that's why it's favorable, because we use less than we expected. Kilogram. So 1.1 per kilo, and you should be able to find the pound one, which is 110 favorable. So what you need to do, you need to do absolutely the same stuff, and at the end you can see that 296 pound is the favorable for the material yield. What does that mean? This means that we really have more quantity or more output than we expected, which is great. Okay, so as you see, if you add 296, right, if you add 296, right, plus 150 favorable, they are both favorable, right? So if you add them together, So the total is 446 pound favorable, right? If you remember this figure, that goes to what? To the material usage variance. To the material usage variance, the one we calculated at the beginning, the material usage variance. And we did say the material usage variance equal mix and yield. Mix and yield. Okay? But as I mentioned at the beginning, we need to break down this in order to find out what is the material mix itself and the yield. So this is the a method to calculate material yield. Of course, there is another method which you can calculate material yield, and this one, another way you calculate it. So 25,000 kilogram did produce. If you look at the question, you can see that 25,000 kilogram was produced. That's for the 3 ingredients. So as you see here, but these 25,000 kilogram, how many units of output it produced? 21,000 units, isn't it? As you see, true? True. Okay. Now, if you look here, the total input of 25,000 kilogram should produce, right? So based on the standard, right? Based on the standard mix, how many units we expected to produce? So of course, if you do this, what you need to do right now, 25,000 kilogram, if you divide it by 1.2 kilogram, you should be able to find 20,833. So again, 25,000 kilogram, if you divide it by 1.2 kilogram, so again 25,000 kilogram, the actual, if you divide by 1.2 kilogram, which is the standard mix, based on this, we are expected to produce 20,833 units of output. But we are lucky that we produce more. We produce 21,000 units. In this case, we are up by 167 units. Of course, it's favorable, right? It's favorable, right? If we want to transfer to pound, what we need to do right now, so 167 pound or 167 units, we need to multiply by the standard cost. By the standard cost. So how we calculate this? As you see here, what you need to do in the question, you've got all these 3, you need to calculate them all together to find one figure. So how you do it? Very simple again. This is the way you do it. You just 600 times 1.1 plus 240 multiply 2.4 plus 360 times 1.5, add them all together, and you need to divide them by 1,000 units. 1,000 units. Or you don't need to. If you multiply this by this, you don't need to divide by 1,000 units. It's up to you. Okay? So that's 1.78 almost per unit. And if you multiply it, you should be able to find it 297 pound favorable. So as you see, there is 1 pound difference between the 2 methods, but it doesn't matter. It doesn't matter. It shouldn't be really the same, really. 100% the same. That's, I guess, I would say because of the decimals here. That's why you should have 1 pound difference. So this is another method. But as you see here, the favorable variance is due to more output being achieved than we expected from the materials input, and that's good news. Okay guys, so this is all to do with material mix and yield. So as you see, the mechanics is very simple, very easy, straight away, and I hope you understand why we are using material mix and yield and what is the purpose of using material mix and yield. Of course, material mix and yield is not suitable for all the products. It just mainly for the products which really to do with related to food items, I would say mainly, but of course not the car. I don't think the car is suitable, because the car is the car, isn't it? So the car, we know that the car has four wheels, and we know the car has one one engine, I guess one engine, I don't know. Yeah, so basically, as you know, the cars are standard, and it's not really interchangeable. So it's not really, you tell me, okay, today we will have four wheels and next year we will have three wheels. So so but with food items, with chocolate and stuff like this, it might be interchangeable. I'll put more nuts, more chocolate, more raisin, more sugar, more water, less water, whatever. So that's the way when they are interchangeable. This is why we have material mix and yield. So the impact could be on cost. Cost could be more, could be less. For example, if you use more nuts than chocolate and raisin, for example, could be more expensive. If you use more raisin than chocolate and nuts, will be cheaper. For example, in terms of equality, so if we use more equality material, or more, for example, more nuts than chocolate and raisin, so that will give the unit or the product more equality, and customer will like it more, isn't it? Because people love nuts. For example, I love nuts. If I want to eat chocolate, I only eat chocolate with nuts. Otherwise, I don't feel its benefit. it benefits me really. So again, that's the way you need to look at the material mix and yield. So again, guys, so have a look at the theory, read the theory, and understand it. And in terms of, as I mentioned, in terms of the sales, mix and yield, and quantity, it's the same way, the same technique, the same mechanics. Just have a look at it, and try to practice the examples within the slides. That's from me, guys. So thank you very much, and have a lovely day. Thank you.